So now we're moving on to a discussion of linear equations in two variables. Before we do that, let's think about what is a linear equation in one variable. So if it's a linear equation, well, I guess it is a linear equation. You know, if I said y equals 2, that's a linear equation. It just happens to be a horizontal line. And if I did x equals 3, that would be a vertical line at x equals 3. So I guess you can have linear equations in one variable. And typically with those, you're given something like 3x plus 5 equals 2x minus 1, and all you have to do is solve for x. So you subtract 2x from both sides, subtract 5 from both sides, and what you're doing here is you're isolating the variable term on the left-hand side. You're eliminating the constant from the left-hand side, bring it over to the right-hand side. So these cancel out, those cancel out, and you end up with x equals negative 6, which is a vertical line at x equals negative 6. So now most lines are two variables, and there's two basic forms. There's what's called the slope-intercept form, and there's the point-slope form. So here in the slope-intercept form, you have m, which is a slope, and b, which is a y-intercept. In the point-slope form of the linear equation, you have the coordinates of one point on the line, x1, y1, and the slope. And you can take this and solve for y and simplify, and you can end up with the slope-intercept form. So a lot of times it's best to use this if you're given the slope and a point, and then ultimately you solve this way because you want to explicitly solve for y, meaning you want to have y by itself on the left-hand side and everything else on the right-hand side. That's the basic concept here. So what is the slope of a line? It's kind of, we think about it as how steep is a line. So if we draw, here's some coordinate system, and we draw a line. So I'm going to draw some different lines. So all of these lines have positive slope, and the slope is the ratio of the increase in the y value divided by the increase in the x value as you go from left to right. So positive slopes are sloping upwards as we go from left to right. And as the change in y for a given change in x, so let's just keep this constant, so if we go over the same amount, each one of these lines with the higher slope will have a, this change will be bigger than this change, and y will be bigger than that change. So these are the formulas that you've seen before. We use m to represent the slope. Qualitatively, it's the rise, the change in the y variable divided by the run, which is the change in the x variable. And you can write it in terms of the coordinates of 2 points. If you know 2 points in a coordinate system, then you can calculate the slope. Now, back over here, I'm just going to draw a few more lines just to finish out what I was talking about. These blue lines are going to have negative slopes because they're sloping downward. The y value gets more negative as you move from left to right. So this is a lower slope, this is a smaller slope, smaller negative slope, and a bigger negative slope, and an even bigger negative slope. So what's, besides just what pretty, knowing if it's steep or not steep, what's the significance of that? Well, if you have a higher slope, you have a bigger change in the y variable for a given change in the x variable. So things are changing more rapidly when you have a large, either negative or positive slope. Okay, so back over here to this formula for the slope. If we're given 2 points, x equals 6, y equals 3, x equals 4, y equals 1, what we can do is we can write x2, we could call, it doesn't matter which one's which. I mean, this could be x1, y1, this could be x2, y2. So that's the choice of 1 or 2 is completely arbitrary, just as long as you're consistent. Anyway, typically I would write x2 comma y2 above these two numbers and x1 y1 above these two numbers, just because it's easier to then look here and make sure you plug in the right things into the equation. So for these 2 points, x2 is, well, let's start here. y2 is 3. So take 3 minus y1, which is 1. And we divide by x2, which is 6, minus x1, which is 4. And we get 2 divided by 2, which simplifies down to 1. So that's kind of the most generic slope, 1, positive 1. And let's just put a piece of graph paper up there just to plot those 2 points and show you that it does have a slope of 1, which is, so okay, we're going to plot these 2 points. So 6 comma 3, so 1, 2, 3, 4, 5, 6, 1, 2, 3. This is that point right there. 4 comma 1, so 1, 2, 3, 4 comma 1. So those are the 2 points. And you can see if we draw a line between those 2 points. Carried away there for somehow or another. Okay, let's try this again. So, you know, you can extrapolate. And I'm trying to get this so that it's exactly in the right place to make this work. So it should go diagonally through these blocks. So positive for a delta x of 1, a delta y of 1. So that's how it goes. So now the question is, you know, what is the equation for this line? All we've done here is find the slope. So there's a couple of ways you could do it. You could actually just look at the graph and say, okay, I've got a slope of 1, and we have y-intercept of 1, 2, 3, negative 3. Right? So you'd know it's y is equal to x minus 3. But what you can do is you can use the point slope form of the linear equation to just use the information that's given. And it doesn't matter which point you use, 4 comma 1 or 6 comma 3, you'll still get the right answer. We use 4 comma 1, so that's x1, y1. The slope we just calculated would be 1. So these are the things we plug in, x1 and y1 and m. The variables are y and x. So we get y minus 1, y1 is 1. It's equal to the slope, 1 times x minus x1, which is 4. So that's the point slope form. Now, if we want to get in the slope-intercept form like we have here, what we do is we would multiply 1 times x, 1 times negative 4, and then we add 1 to both sides to solve for y. Get y is equal to x minus 3, which is the same thing. Okay, so we just did that. Yeah, we just talked about this. Now, in the previous case, I wasn't given the slope. I had to calculate the slope. But you know, in this case, if I'm given a problem where it says find the slope-intercept form of the equation of the line that passes through the given point, this one right here, and has this indicated slope, negative 2, the way you do it is you use the point slope form to get the equation, and then you do the algebra to solve for y, just like we did. So let's go ahead and do this. So again, I'm going to write x1, y1 above that. We already have m. So we get y minus y1 is 6 is equal to m, which is negative 2, times x minus x1, and x1 is negative 3. So I'm subtracting negative 3. So the first thing you're going to do is just going to, if you have a negative of a negative, it becomes positive, or you take the additive inverse of the negative number, it becomes positive. So I get x plus 3. Then you negative 2 times both of those terms. So we get negative 2x, negative 2 times 6, negative 2 times 3 is negative 6. And we add 6 to both sides. And in this case, we get just y equals negative 2x. So there's a plus 0 here. So the y-intercept would be 0. Slope would be negative 2. So let's just do the graph of that as well. How would we do that? Let's put a page in here. So we're going to plot the point. So the point is negative 3, 6. 1, 2, 3, 4, 5, 6. Okay. So now the slope, what that says is you go over 1, down negative 2. So we always go over 1, and this is whether we go up or down. Down negative 2. So we're going to, and then we'll go over 1, down negative 2. So here we are, over 1, down negative 2. 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 So we'll start here, and we'll go through those points, and we'll try to make sure it follows that same trajectory this direction, and now everything should be good. Okay, so there it is. So that's the equation, y equals negative 2x. That's it. So you can see that it does go through the origin, so the y-intercept is 0. So this is how you do it graphically. Plot the point, then just plot some extra points following the slope definition. Or you can use the point-slope form of the linear equation. So here's another one. So once you pause the video and then do it. So you're going to substitute these things in here and then algebraically solve for y. So don't, if you didn't pause it, because it's not going to be good just watching me. You got to do things yourself. Okay, so let's check the answer. And again, I'm going to write x1, y1 up here. So y1 is negative 5. So we have y minus negative 5 is equal to the slope, which is 3/4 times x minus the negative 2. So again, we're going to take the additive inverse of negative 5, which is positive 5. Same over here, the additive inverse of negative 2, which is positive 2. Multiply this out. Now this is 3 times 2 is 6, 6/4, but that simplifies down to 2/3, so we'll go ahead and do that. And then the last thing we're going to do is we're going to subtract 5 from both sides. Now I'm going to use 5 here, but over here I've got halves, so actually what we're going to do is we're going to show you just a different thing. So just instead of doing it this way, okay, like that, and going, another way you can think about it is, so I'm going to erase this just to show you what another way of thinking about this is, if you take a constant and you move it to the other side of the equal sign, it becomes the negative of that. So positive on the left hand side, it becomes negative on the right hand side. So if I do that, I'll get y is equal to 3/4 x plus 3/2 minus 5. Now, why is that different? It's just because now what you can do is you can have everything on the same line, and then you can change these two terms to have a common denominator, which is 2. So to get 5 into a fraction that involves 2, you just multiply 5 by 2. So you get 10 divided by 2. So 10 divided by 2 is 5. So those are equivalent to each other. And now that I have a common denominator, I can just add the numerators together. So I've got 3 plus a negative 10 all over 2. And you may say, why did you do 3 plus a negative 10 instead of 3 minus 10? And it really, either way is fine. It's just, here you have 10. Well, for one reason, you can think about just adding stuff together. Subtracting is the same as adding the additive inverse of 10, which is negative 10. You could also think about it on a number line basis. So if I started at 3 and I subtracted 10, that means I go 10 to the left. So first I'll go 3 to the left, which gets me to 0. And that leaves me with 7 more, so I go into 7, negative 7. So this is 7, this is 3. 3 plus 7 is 10. So just it's kind of a new way of thinking about subtraction. So this should have been negative 7 halves. And because this is odd and this is even, that's as far as we can go. So there you go. This is the answer. Now, before we go to the next one, you're like, oh, we've done this so many times. Algebra 1, Algebra 2. And the thing is that even when we get to calculus or we get to linear algebra, a lot of them ultimately come down to dealing with linear equations as an approximation to maybe a nonlinear situation. And sometimes it's much easier to solve linear equations than it is to solve nonlinear equations. And if the linear approximation is close enough, then, or in the case of calculus, what you do is you do this limiting process with things that are pretty simple. A line or finding the area of a rectangle. Both of those you've done forever. It's just the application of it. Okay, excuse me. So the last thing we did was we were given the point and the slope. The next thing you need to be able to do is find the equation for the line passing through 2 points. We actually did this earlier. We're going to do it again. So the procedure is, first you find the slope between these 2 points. Then you take that slope and either one of these 2 points and use it with the point-slope form of the linear equation, wherever it is here. And then you do the algebra to solve for y. So the slope is y2 minus y1 divided by x2 minus x1. Again, I'm going to write these up here like that, so that makes it easy to copy over. y2 is 5, y1 is negative 1, x2 is negative 5, x1 is 5, positive 5. So I get 5 plus 1 divided by negative 5 minus 5. Or the slope is 6 over negative 10. And we can simplify that down to put the negative in front of the fraction. 6 over 10 is 3 over 5. So that is my slope. And I'm going to use this one as my point. Again, it doesn't matter which one I use. So let's write down the point-slope form of the linear equation. Okay, so I've already got them labeled here, so it's perfect. So I have y minus negative 1 is equal to negative 3/5 times x minus x1, which is 5. Okay, first thing, the additive inverse of negative 1 is positive 1. Let's go ahead and multiply it. So we're doing two things. We're dealing with this negative of a negative. And then we're going to multiply out these terms. So you're going to have 3/5, negative 3/5 x, and negative 3/5 times negative 5. So that ends up being positive 3. These 5's cancel out, the negatives cancel out, just end with 3. Then we subtract 1 from both sides, or the other way we looked at it is you can take the negative 1, move it to the positive 1, move it to the other side, it becomes negative 1. Then you can combine those two like terms like that, and voila, you're done. Okay, now we got a few things here. So parallel lines are lines that are in the same plane that never intersect. And as a consequence, the relationship between the slope of two parallel lines is they have the same slope. So parallels have the same slope, and you could say, what's the word? It's not congruent. It's when one line lays over the top of another line. Might be collinear, might be the word. So, you know, if you have two lines that are the same, they have the same slope, and they also go through the same points. So if you have these two lines, which are parallel, have the same slope, but they, for a given value of x, say, here's my xy coordinate system, for a given value of x, they have different y values, but the slopes are the same. What about the relationship between the slope of two lines which are perpendicular? So what is perpendicular? It means they intersect and they have a 90-degree angle between the two. So it'll be like that. You know, they don't have to be horizontal, vertical. They just have to have a 90-degree angle between the two lines. So here's the answer. Two lines which are perpendicular have slopes which are negative reciprocal of each other. So if the slope's positive, the perpendicular line will be negative, but they're not the same. There's this negative reciprocal. So here's an example. I was just seeing what I had here on my notes. So if the slope of one line is 2, what is the slope of any line that is perpendicular to that? So let's say m equals 2, then the line that's perpendicular, any line that's perpendicular to that, will have the slope negative. So it's negative, and the reciprocal is just 1 over the slope. So this, for a whole number, you're going to end up with a fraction, 1 over whatever that is. Let's look at another example. So let's say the slope is 5/3. Then the slope of a line that's perpendicular to that will be equal to negative 3/5. So if you start with a fraction, you just flip the numerator and the denominator. It's negative 3/4 is the slope. Then the slope of a line perpendicular to that is going to be positive. Let's change the negative to a positive. Here we change the positive to a negative. So, and then you flip the numerator and the denominator. Let's say the slope is equal to negative 1/5 of one line. Then the slope of lines that are perpendicular to that line are going to be equal to positive, and you flip the numerator and denominator, which is 5 over 1, which is 5. So in the case of a fraction where you have 1 in the numerator and a whole number in the denominator, you're going to end up with a whole number here. You can simplify that. If it starts out as a fraction that's in its simplest form, the result here is going to be a fraction, just the opposite sign. If you start out with a whole number, the slope of the lines that are perpendicular to this line, you're going to end up with 1/5, 1/2, 1/27, whatever. So here's a problem, kind of like what we had before. It says write the slope-intercept form of the equations of the lines that through the given write the slope-intercept form of the equations of the lines through the given line parallel to the should be point there. The given line. The given point is that one. Parallel to the given line, perpendicular to the given line. So all we have to do for the given line is figure out what the slope is. So you can do that by taking that and solving for y, which will put it in the slope-intercept form. So I'm taking 4x, move to the other side, and then I'm going to divide everything by -2. So that'll get me y is equal to -4 divided by -2 is +2, and I'm going to get -3/2. Now, this part is irrelevant to answering the question, because all we care about is what is the slope of the original line. So part A is we have a slope that's the same because it's parallel. Slope equals 2, and the point is 2, 1. So at that point, we can use the point-slope form of the linear equation to get an equation, and then we'll solve for y. Okay, x1, y1, slope y minus y1, which is 1, slope, which is 2, times x minus x1, which is 2. Multiply this out, 2x minus 4, move the -1 to the other side, 2x minus 4 plus 1. So we get y equals 2x minus 3. So that's the answer for the first part. You see it has the same slope. 2, 2, there's 2, there's 2. They have different y-intercepts because they're not the same line. Okay, the next one, we already know the slope is 2 for the original line. So for part B, if we put slope of any perpendicular line is going to be -1 divided by 2. So there's two ways you can think about it. Reciprocal is 1 over the number, or you can think of this as 2 over 1. So the reciprocal, you just switch the numerator 1 to the denominator and the numerator to the denominator. So that's my slope, and my point's the same as the previous problem. So if we take the point-slope form of the linear equation, plug in x1 and y1, so that y1 is 1, slope is -1/2, x is the variable, x1 is the number, multiply this times both terms, so you get -1/2 x. Get -1/2 times -2 is going to be +1. 2's cancel out, negatives cancel out, you're left with 1. Then what we'll do is we'll move this -1 to the other side. So this is the -1 moved to this side, so it becomes +1. So you get y is equal to -1/2 x plus 2. So there you go. That's the equation of a line that's perpendicular to the original line because it has a negative reciprocal slope and goes through the point 2, 1. So let's see where I am. Okay, 4. no more problem. So we'll do the same thing here. So again, put this on pause and do just what we did in the previous problem. Don't be cheating now. Okay, now that you got it done, let's check it out. Check her out here. So it's a little bit more difficult because it's got fractions and stuff, but not that big deal. Okay, so the first thing is we're going to take the equation, solve for y. So I move that to the inside, it becomes negative, divided by 4. So you get negative 3/4 x plus 7/4. Again, the only thing that's important here is the slope. So now part A is the parallel part. So we have a slope of negative 3/4, point of negative 2/3 and 7/8. So point slope form of the linear equation. This is x1, this is y1. So you get y minus y1, which is 7/8. Is equal to m, which is negative 3/4 times x minus x1. Get that. Okay, first thing, simplify that. So it becomes plus 2/3. Multiply this out, both terms. So when you multiply this, you get 3 times 2, which is 6. Get the negative sign times the positive sign is negative. 3 times 2 is 6. 4 times 3 is 12. You can see let's go ahead and simplify that before we move on. So 6 divided by 12 is the same as 1 divided by 2. Move this to the other side. So it's negative here, so it's going to become positive over there. Find a common denominator between the two constant terms. So to get this to be an 8, we multiply the numerator and the denominator by 4. So we get 4/8, which simplified is 1/2, plus 7/8. So now we can add them. 7 minus 4 is 3. So we get first term same, plus 3/8. And that's the slope-intercept form of the equation that is parallel. Okay, now what we're going to do for the perpendicular part is we're going to take the slope and take the negative reciprocal. So the original slope was negative 3/4. So the slope of the perpendicular lines is positive 4/3. So we have this, and we have that same point, which was negative 2/3, comma 7/8. Okay, point slope form in the linear equation. Okay, this is x1, y1. So you get y minus y1 is equal to m times x minus x1. First thing is just to get rid of this, simplify here. The additive inverse of a negative number is a positive number. Multiply this out. thirds x. Here, you're going to 4 times 2, which is 8. 3 times 3, which is 9. Move this to the other side, it becomes positive. So we get 4 thirds x plus 8 ninths plus 7 eighths. So what is the common denominator? Well, actually it's 72, because these have no common factors. 3 times 3 is 2 times 2 times 2, so it's the smallest common denominator is going to be the product of those two, which is 72. So what you'll get is you'll need to multiply this by 8. 8 divided by 8 to get 72. So that's 8 times 8 is 64. 8 times 9 is 72. Here we have to multiply by 9. 9 times 8 is 72. 9 times 6 is 63. 9 times 7. Is that right? Okay, so then you add the two together. So you get y is equal to 4 thirds x. 63 plus 64 is 127. So 127 over 72. And I think that's as far as you can go, because you can't divide them by 3, 4, 5, 6, nope, 9, 7. Okay, so that's it for that section.